chemistry, there are three definitions of acids and bases: the Arrhenius, the Bronsted-Lowry, and the Lewis. What we can see in these boxes is that the definitions build on each other. So everything that is an Arrhenius acid and base is also a Bronsted-Lowry acid and base, and is also a Lewis acid and base. The first definition of acid and base is the Arrhenius definition. This one states that acids will dissociate and release an H+ ion, or a hydronium ion. This also states that bases will release a hydroxide ion. So for example, if you took HCl, which is a common acid, and you place it into water, what will happen is it will dissociate into a hydronium ion plus the chlorine. And if you take a common base, such as sodium hydroxide, and you dissociate that in water, it will form a hydroxide ion and a sodium ion. So as we can see, an acid dissociates to release an H+. A base dissociates to release an OH-. The next definition is the Bronsted-Lowry definition. This one states that acids donate hydrogen ions while bases receive hydrogen ions. And we can see that right here in this example. Here we have sulfuric acid, H2SO4, plus water, resulting in H3O+ and HSO4-. So we can see that sulfuric acid, or H2SO4, donates one of its hydrogens to this water, and that water becomes H3O+. And now that this sulfuric acid has lost a hydrogen, it's now HSO4-. So we can say that sulfuric acid donated a hydrogen, making it a Bronsted-Lowry acid, and we're going to say that water received a hydrogen ion, making it a Bronsted-Lowry base. The last definition that you should know is the Lewis definition. This one is kind of similar to the Bronsted-Lowry definition, but with some key differences. We can see that acids are electron receivers, while bases are electron donors. So we can see it in this example. Here we have NH3 plus BF3. What we can see is that NH3 has a lone pair that has two electrons just hanging out right here. And boron wants to complete its outer shell. So what will happen is NH3 will donate this lone pair in order to form a covalent bond with BF3. And as a result, you will form the compound NH3 BF3. So what we can see is that NH3 donated an electron, making NH3 the Lewis base, and we can see that BF3 accepted electrons and it received electrons, making it the Lewis acid.